Alright, let's look at the homework 14, problem number 1. Alright, so we want to find the area of the disk R is less than or equal to 2a sine of theta. Alright, so to visualize what this disk looks like, what we can do is I'm going to just multiply both sides by R, so that we have R squared is less than or equal to 2a R sine of theta. Alright, then I'm gonna rewrite it in rectangular coordinates. R squared is x squared plus y squared. Right, this is less than or equal to, we have a 2a. Alright, so R sine theta is actually y. Alright, so this is going to be equal to, alright, put everything on one side, so you have x squared plus y squared. So I'm going to subtract 2ay from both sides. So minus 2ay is less than 0. Alright, so what I'm going to do is I'm going to add a squared here and a squared there, so we can complete the square. So this is x squared plus y minus these three. Right, these three guys can be written as y minus a squared is less than or equal to a squared. Alright, so this is going to be just a disk. So you have a disk. Alright, center at x equals 0 and y equals a. So let's say here is a. So that's the center. And the radius is a. So we can see that the circle we're talking about, it's this circle right here. Right? And we want to find the area of this disk right here. Alright, so let's set up an integral. Let's use the polar coordinates. So area of the disk is going to be equal to, alright, remember that it's going to be a double integral, and the area element for the polar coordinate is r dr d theta. Right, so for a fixed theta, so here's the fixed theta. Right, and r is going to start from, so this is going to r is equal to 0, and here is along, so r is going to be 2a sine of theta. Right, so r value goes from 0 to 2a sine of theta. Right, so in order to swipe the whole thing, theta is going to start from 0, and then increase the theta value and all the way to, so this is pi over 2, and all the way to pi. So you can see that that's going to be 0 to pi. Right, then you can compute this. Alright, so answer, it's pretty clear. So you have to actually work out the double integral, but the answer is going to be, so radius is a, so area, it has to be pi a squared. But you need to fill in the gap. Alright, that's it. I hope that this was clear.